Okay, so this video is on how to find the exact axis of symmetry and vertex of a parabola using algebra by factoring and using the fact that the vertex is the midpoint. And it assumes that you already understand the what an axis of symmetry is and what a vertex is by graphing and by table of points. So if you haven't understood that or watched the videos on that already, then you should do that first, okay? All right, so we're gonna start with actually example 3 from that particular video. So if you happen to remember, the equation for example 3 was y equals 4x squared minus 8x minus 5. And my instructions are find the vertex and axis of symmetry of this equation. So I'm given this, and what I'm going to do is I'm going to explain this 2 or 3 different ways. First, I'm going to give you the big idea of where the algebra comes from, and then I'm going to actually do the method and explain the method step by step, and explain how it relates to the concept that I already told you. But if you prefer the method over the concept, then that's okay, because you'll be working through it correctly. So here's the big idea first. So the big idea is that we're taking advantage of what we learned before about a vertex and axis of symmetry in a table of points, which is that in a table of points, the vertex is always the exact middle of where all the repeating y values happen. So if you have a repeating y, like -5 and -5 and 7 and 7, you know the vertex is always going to be exactly in between those points. So I can take any repeating numbers like 7 and 7, look at what the x values are, which are -1 and 3, find what's exactly halfway between -1 and 3, which 3 plus -1 is 2, divided by 2 is 1, so that's going to be the vertex. Equally, I could have also taken this coordinate here, -5 and -5, because they're also the exact same y value. So if I take those, the vertex has to be exactly halfway between them because these points revolve exactly symmetrically around the vertex. So if I take a look at the repeating y value, then look at their x values, which are 0 and 2. This is 0, -5. This is 2, -5. I add them and find the exact halfway point. 0 plus 2 is 2, divided by 2 is 1. Again, I will find the exact vertex. So it doesn't matter which repeating y I choose. It just matters that it has to have the same y value, and I choose those two together to add and divide by 2 to find the exact middle, and that will be my vertex, which also will help me find my axis of symmetry. So I'm looking for a systematic way to find, because I'm using an algebra method, to find a repeating y so that there's always 2 y values that are repeating and are exactly the same. Well, 2 such coordinates that we find all the time are the x-intercepts. So for example, if I were to graph a rough picture of this parabola over here without actually knowing what the exact vertex was, we're pretending that we're doing this from the beginning, that we haven't done this before, we don't know what the vertex is. And if I happen to see a graph of this, someone said this is the graph, but you have to find the exact vertex value, I would know using this equation how to find the x-intercepts. And the x-intercepts have the exact same y value. So whatever these x-intercepts are, their y value is going to be 0 and 0. So if I can just find these x values for the x-intercepts, I know that the vertex has to be smack in the middle of those 2 coordinates. So that's where the method for finding the vertex and axis of symmetry using algebra comes from. So step 1, which I have given you some access to somewhere of the notes on how to find a vertex, is to factor your quadratic function. This is my quadratic function right here. A quadratic function is just the equation for a parabola. Factor it and then set it equal to 0 and solve, okay? So that's step 1. So I'm going to factor and solve for the x-intercepts. So 4 times 5 is -20. I'm looking for 2 numbers that multiply to -20 but add to -8. So I try 1 times -10, doesn't work. 2 times 1 times negative 20, excuse me, 2 times negative 10, that does work. And it adds to negative 8 because the bigger number is negative. So 2 plus negative 10 is negative 8. So then I'm going to replace this middle value with plus 2x minus 10x. And if you don't know how to factor or don't remember, you're going to need a refresher on that because this assumes that you did learn it very well. All right, so I'm going to pair it up like this. Then the GCF of 4x squared and 2x is 2x. So I pull that out. I'm left with 2x plus 1. Pull out here from negative 5. That's left with 2x plus 1. Then the GCFs on the front go together in one parentheses, and 2x plus 1 is left in its own parentheses. That equals 0. Set each parentheses equal to 0. So 2x minus 5 equals 0. If I add 5 to both sides and divide by 2, that x is going to be 5 halves. Do the same thing here except subtract 1. So that's going to be x equals negative 1 half. So my x-intercepts are 5 halves, 0, and negative 1 half, 0. Step 2 is to find the halfway point between the x-intercepts because the vertex is exactly halfway. So the x value is 5 halves for the first x-intercept, and negative 1 half is the second x-intercept. And I'm just going to label that these are x-intercepts right there. So these are the x values of the x-intercept. Okay. Step 3 is to add these and divide by 2. So 5 halves is really 2.5 plus negative 0.5 divided by 2. That's going to be 2 divided by 2 equals 1. Step 4, this is the x value of the vertex. So my vertex is 1, and then I don't know what the y value is yet. So I'm going to plug in 1 into my original equation for the x in order to solve that. So 4 times 1 squared minus 8 times 1 minus 5. So that's going to be 4 minus 8, which is negative 4, minus 5 is negative 9. So my vertex is going to be 1, negative 9. My axis of symmetry always goes through the x value of the vertex, so it's going to be x equals 1.